Okay, so these are the ones that they only mark you 2 things, and we need to find the third. Okay, we need to find what they don't tell us, but we should already know from theorems that we've learned. So you may have vertical angles. You may have same side interior angles. You may have reflexive sides. Remember, that's when they shared a side. You might have a reflexive angle. That's where they shared an angle. So right now, they want us to write what they already give us. So if you look at this picture, they give us that side A to B is congruent to side D to B. Okay, that's the first thing they mark. They mark this, A to B and D to B. Okay, yes, no, 62. This should be glued in on page 62. Okay, so that was a given. Your other given is E to B is congruent to C to B.
C to B, E to B, C to B, C to B, what? B to B.
B to B?
Yes. You never heard of a B to B?
Yeah, never good.
A B to B. We talked about BBs yesterday, remember?
Dry out.
With Tay's silly joke. Okay. What piece of information can you get from this picture that they just didn't mark?
A and E and C and D.
You can't prove that.
Oh, well, I'm sorry.
What angle?
The entry, like, you know how it crosses.
Okay, so Bobo says I can mark this and this. So I can say that angle ABE is congruent to angle DBC. Why can I say that? What theorem tells me that I can say that? They're what? Somebody said it. Vertical angles. These are vertical angles. Okay? You can't just say that something's congruent to say that it's congruent. You have to have a theorem or a postulate behind it.
So what's other theorems?
Okay. So you can use anything. You can use your same side interior angles. You can use corresponding angles. You can use vertical angles. You can use supplementary angles. That's why we talked about all those.
So we're going back to those?
You can use any of it. Yeah. So this is why I taught you those first. I promise there is a method behind my madness. Okay. In this one, the 2 pieces of information that they give us is MN. So side M to N is congruent to side P to N. So these 2 sides are the same. And they also tell us that angle NQM is congruent to angle NQP. Okay, those are your right angles here and here.
So they tell us that's congruent.
Huh?
They tell us the same thing. Right?
The same symbol?
Look the same, because like I think you have to have a little slash.
Not necessarily. They can use a right angle. If they're both right angles, they're congruent.
What did you
Okay.
take to make them equal? Like what did you like you know how we had vertical angles for this? What did you have?
That's just written on there. So MN has 2 dashes on it. PN has 2 dashes on it, which tells you that they're congruent. They tell you that. So your givens are what they already tell you. And we know that this angle's a 90 degree and this angle's a 90 degree, so they are also the same. Okay, because they're already marked. Okay, what piece of information do they not tell us that we can assume is the same?
Is it a side angle?
N and Q.
It's N to Q. Take a look at my 2 triangles. They share this line in common.
So I got that right.
Yes. So we can say NQ is congruent to NQ. And because they share it, what do we call those?
There's sides.
There's a word that we use for shared.
Congruent.
Wait,
So-
hold up.
We learned this on the Hidden Figures page. Back on page.
Reflexive sides.
Reflexive sides. Okay? These are reflexive sides, which means that they're the same. So we talked about that here. See how these two triangles share that one? Yeah. Okay. Okay. Take a look at this one.
That looks complicated.
Woo! Okay, so we've got parallel lines. So right now, all they tell us is that angle SUT is congruent to angle USR. So this angle and this angle are congruent. Okay, that's all they show us in the picture.
When you look at this, how would you know where to start? Or like, say
I
you say-
would automatically look and say, do they share anything in common? And then because they're showing you parallel lines, I would jump to, do you have alternate exterior angles? Do you have alternate interior angles? That type of an idea. So first things first, looking at this picture, does it share anything in common?
The line.
The side.
What side?
S, the T, and
With,
No. Share in common, which means if I remove it,
SU.
STU. Okay, so they share this line in the middle, right here, STU. So we can say SU is congruent to US.
Can you just say anything when they connected?
Miss Smith.
Yes,
I'm so sorry, but
you're fine.
what is that?
What?
What is SUT and USR?
Angle SUT, angle SUT. So this angle right here, and angle USR. So this angle right here. So when you label angles, you label them in threes. Okay, you always label angles in threes. And the middle one is where the angle is. So U and S. So U and S. Okay. Okay, so you know that SU and US are the same side. So those are reflexive. Now, let me draw you this picture with some things missing. So if I've got a parallel line here, and a parallel line here, and a line that comes down like this. Without these two sides here, we know that this is parallel to this. So what is this angle and this angle?
They are
The same.
They're the same. Why?
alternate
Because
interior.
Alternate interior angles. So I can mark that this angle and this angle are the same. So angle UST is congruent to angle SUR
we need to, like,
because they're alternate interior angles.
right, everything's defined and we need to put it.
You only need 3 pieces of information. So once you get 3, you're good.
We only found.
Is that,
They gave us 1, so we only needed to find 2.
all we're doing is finding the similarities right now.
Because now that I have all this information, I can say that the 2 triangles are congruent because of side or angle side angle.
I thought you said like congruent and similarities different.
It is. We're not doing similarities yet. We're still on congruence. Okay. This is the hard part when they don't mark everything. Because then you've got to use your knowledge and work your way through it. When I went through these classes, we literally had to write out these long formal proofs. Just be glad that they're not making you do that anymore. They're a little bit torturous. We will work some more on this tomorrow too with review. I'm not going to leave you hanging high and dry. I'm not like that. Come on now. Got your back. Okay, take a look at the next one. What do we know?
Angle
X, Y, Z, X.
Okay, you said angle VWX.
It's congruent to VYX.
Good. It's congruent to angle ZYX
How do you know off the bat that they're congruent?
because they're marked.
So, if they're
So angle-
marked, they're always congruent?
Yes. So if you look, VWX is this angle right here. Okay. This angle and this angle have the same marking, which means that they're congruent. If they have the same marking, that means that they're congruent.
If they have markings, but different markings.
If they're different markings, so like if Y had 2 slashes instead of just 1, they're not congruent. Okay, they have to be the same symbol.
Could another angle be congruent to another, or no?
If they would mark it, yes.
I'm sorry.
No, could like Z be congruent to B, to W, or congruent to Y, or that's not even?
Yeah, that could, if they would have marked that instead, yes. It's all depending on what they mark for you.
So if one side can be congruent and one side cannot be congruent. So which one for that? If one side's congruent, what would you like to say?
The triangles aren't congruent then.
All of it. All of it. Actually,
Yes.
okay.
What?
Okay, so we know that. What else do we know?
Yeah, I'm vertical.
Stop still.
What have they marked?
The ZY
ZY is congruent to VW. Okay, now Bobo, what do they not have marked that we know because of our theorems that we already know?
They got X, so they're vertical.
Okay, this angle right here and this angle right here are vertical angles. So I can say that angle VXW is congruent to angle ZXY. And these are vertical angles.
Would you put 2 lines?
No.
Could they have got one angle more?
Oh, yeah, technically you're right. Technically we should do this because they're not congruent to Y and W. Look at Bobo being technically inclined. Huh? Bobo said, shouldn't you throw an extra line here because these aren't congruent to this?
Wait.
He was right.
Can you come here?
Yes.
How do you know?
That's it, I'm not ready.
You could have done TUS and this.
I need my hair done, bro.
You got it. Okay. Take a look at this one.
Yeah, that's complicated.
If all 4 angles are 90 degrees, what is the shape? A rectangle. And if this is a rectangle, that means this side is congruent to this side. This side is congruent to this side.
Give me the 5, they put that too.
And they share this one in common. So they're congruent. We've got congruent triangles. You could use side angle side here. You could use side, side, side. Okay, so we know that angle BCD is congruent to angle DAB. Dab. You're right, dab.
My dab. Look at my dab. Dab. Yeah, ugly.
That used to be my favorite song. I promise y'all.
Ilana, I'm not going to practice like this.
Okay,
Yes, you are.
You know what? I would.
we can state that side B to C is congruent to side D to A. And we can also state that side A to B is congruent to side C to D
Wait,
because it's a rectangle. Careful. When you label B to C, it's going from, or I'm sorry, B to C. So it's gotta go D to A. But this is your 90-degree angle, this is your 90-degree angle, so A and C are the same, so C and A have to be the same.
What?
But they're on.
I know you want to
Okay,
Hey, what that slash mean?
what does what slash mean?
Where does it say?
Because? It's my shorthand for because. Okay, rectangle.
What?
I shorthand.
I know, it's okay. I just wanted to know what it is.
I never made it to get my candy bar. Look, when she told me I was gonna have to stay in the vault, I was like, I'm out. No. If you get locked in the office with them when they do a tornado drill, you have to go in the vault.
Oh, no, no, no,
It's a vault.
no, no.
It's a vault.
The vault, like where we keep our safe, the money safe that we keep all our stuff in.
It's a
So,
vault.
when we
have money?
Right,
After school, after school right now, she's already made the deposit, so if we have money we have to give her, she puts it into the vault for tomorrow to deposit. And I'm not getting in that vault. Not making it in the vault.
Money.
Right, so there's all kinds of other stuff in the vault, I'm not giving her the vault.
Money will be in that. Okay.
Oh, okay.
This one is.
Okay,
I mean, but we got, that's why I put this. I've been here for like 20 years.
63?
so this will eventually glue onto page 63 when we are finished. Okay, it'll glue in on 63. So we had several different ways to prove triangles congruent. We had side, side, side. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg.
You can write something.
All right, that's nice.
So all of these will tell you that a triangle is congruent. Okay. I also have 3 theorems that will tell you that triangles are similar. So you have to be careful. Similarity has what we call angle, angle. They also have a side, angle, side. And they have a side, side, side.
That's the only 3.
There's only 3.
So what's the difference?
Okay. So the difference between congruence and similarity is I have to prove that 3 sides are congruent, which means 3 sides are equal. In similarity, I have to prove that they're proportional. So I'm going to show you how to do that. Okay.
I knew it.
So if a figure has 2 angles on one triangle that are equal to 2 angles on another triangle, you can automatically say they're similar. Okay. Similar triangles have equal angles. So if you open this up, are the 2 triangles similar? If so, state how. So I've got 2 different triangles. I've got this one.
Stop. Which one are you on? Oh.
On the left. Okay.
Can I get a marker? Does anyone have a picture?
I do.
Okay. So remember what theorem we're trying to prove here. I'm trying to prove angle, angle. So right now I've got 2 triangles, and all that they tell us is that this angle is congruent to this angle. Those 2 angles are the same. Well, we said in order to use this theorem, I need to have 2 angles that are the same. Do they share another angle then it's the same.
Yes.
What?
The bottom one. Wait,
WVX.
CWA.
V. I mean,
X.
WVX.
Wow.
X,
Okay,
V,
W.
It's a parallel.
W.
Nigga.
You can't prove that those are parallel. It didn't tell you that. Can't say that.
X and V.
Oh, so they have to tell you it's parallel?
They have to tell you.
X, V.
What, Alfredo? X.
I just said that.
Oh, wow.
You didn't hear me, but I'm right here.
I'm sorry.
Okay, Alfredo.
Okay, take a look. This is my first triangle. This is my second triangle. They share X in common. That is a reflexive angle.
X and what else?
I thought you already said it.
Oh, wait. Oh, it's a big triangle and a little small
And the little triangle inside of
Oh,
it.
I thought
I don't see it.
Guys, I got them highlighted in 2 different colors.
But
Woo!
I thought I thought the bottom half was
So-
supposed to be a
Hey, they
triangle.
look the same on this one.
Here.
It's the same as one.
Here, let's do it this way. Here's your small one, and here's your big one.
Okay, I got it.
Okay, you see it now?
She had to do it.
Oh, I had to be extra. Y'all made me extra.
We didn't do it.
I did. Okay, so because they share angle X in common, we can say that angle X the triangle WXV is similar to triangle, and it's the same thing when you label these triangles like you do congruent. So W goes with what on the big triangle?
Z.
Z. X goes with X, and V goes with Y. And this symbol means similar. Okay. All you did was take away that equal sign. Okay. So a congruent sign is the similar sign with an equal sign below it, and the similar sign is take out that equal.
I wonder who made this stuff up.
They could use something good for
Genius people.
Miss Smith, you were
Genius people.
Yes.
That's easy.
Was she right?
Oh, she's talking about your head.
Guess what? I don't care.
Okay. So, guys, they don't tell us anything about this one. All they tell us in this one is JK is parallel to GF. That's what that means. That's what those little things are. So, Bobo just said I've got vertical angles. I got vertical angles. He does love vertical angles.
Something you want to tell us about?
Yeah, go ahead.
So, these are vertical angles. What else do I have?
F, G, H,
Intersection
J,
Y.
K, L, H.
You said F, G, H. So this one,
Yes.
okay? And what?
And the other one at the bottom.
Okay, down here.
Yes.
Okay, why can I mark those?
Because
But they're alternate interior.
Yeah,
They're alternate interior angles.
and then
These are alternate interior angles. Okay, here's your parallel lines. So they're inside the parallel lines. One's on top of your transversal, one's on the bottom. So they're alternate interior angles, which means that they are congruent. The two that I marked,
the blue ones.
these blue ones that I marked. I could have also said that J and F are the same for that same exact reason.
We have to mark them like 3.
You only need 2 to prove similarity. So once you have 2, you're good. Because if 2 are the same, that third one has to be the same. Because they all have to equal 180, remember? Yes.
Can we talk?
And I know what that is.
So these are your parallel lines. Okay.
Well, I'm gonna have to-
This is your transversal. So if I do, because you need it without that other line. I got you. So if you've got these 2 parallel lines and this line that cuts up through there, I can say that this angle and this angle are congruent because they're alternate. One's on this side of the transversal, one's on this side, and they're inside these parallel lines.
I got it.
Does that make more sense without that extra line in there?
How do you know that the other one will
You can, so I can also do, instead of marking those two, I could have done the same thing with these two. This one and this one are also congruent because they're alternate interior angles. So I could have marked those two instead of that one. I could have marked the two sets of alternate interior angles instead of the vertical.
I think the James like just like kind of just put me on training.
Are you talking about just how it looks in the picture?
Well, you said on the bottom, this is kind of like,
Shut up, bro.
You sitting right beside him and then tell that.
Right,
The whole time.
Don't look where the letter is, look where the angle being
Then why
formed.
you tell him to tell his music down?
The angle being formed is here, the angle being formed is here.
Got your own
So
little-
this
No.
one's below your transversal, this one's
I
above
ain't
your
ate nothing.
transversal. That,
Don't feed her
Right.
nothing. If anybody got any food, don't feed her. Let her starve.
okay, so we can say,
they're not, it's really bad.
guys, enough. We can say the triangle KJH is similar to triangle GFH. I have a feeling we're gonna have to push our test to Monday.
You said
Yes.
what?
Why are we doing
They're
this?
similar.
This is on the test?
Huh?
This on the test? Oh, yeah.
Another young Miss
Monday.
Harrison.
I have a feeling we're gonna have to push the test till Monday.
Can we please?
Cause this,
Right down.
Hello.
Let's do a class vote.
Shut up. Oh, my.
Let's not, because we just gonna do what Miss Smith wants to do. And Miss
Right,
Smith
right.
said we gonna push it till Monday, so I
Can
mean,
we still do
just
fun?
roll with it. Roll with it. Right. There ain't no need to trip.
Unless
When you
fall.
trip, you get hurt.
I love you so much.
Period.
Period.
No
You should
shame
know.
on
You should know.
No cap.
Period. No
No, it's period.
One.
Okay.
I thought it was
I'm trying to tell you. You said it.
The angles are congruent. But if I can prove that two angles are congruent, my triangles are similar. Okay. Yeah, we gonna spend some extra days on this because we just woo. Woo. All right, so let's get through this. Okay. I am not against spending an extra day on this if that's what we need to do. Okay. It's all good. I just got to email Miss Moore and tell her that Bobo ain't coming till Monday.
I ain't coming, period.
You ain't going?
I like it. I got like 100. That's fine.
I mean, I'm okay with that. You just have to sign a piece of paper every time that says that you refused.
Hey, do you guys
Because you have them, so I have to offer them, and then you just have to sign the form that says you don't want to do it. You have that option. That's okay. Okay, so your second theorem says if I can prove that one angle is the same and two of the sides are proportional, then I have similar triangles. Okay. Notice that this is side, angle, side. So the angle has to be in between the two sides. So right now they tell us that this angle is congruent to this angle. Check one for that. So we're trying to do side, angle, side. So angles are a check. We're good. Okay. I have to prove that my sides are proportional. So in order to do that, I need to set up a proportion. Okay, so let's take a look at this. 4 should go with what number on that second triangle? 6. 6 should go with 9. So you've got 2 ways to set this up. Okay, so I can set it up as triangle 1 is 4 over 6. And triangle 2 then, because 4 is on top and 6 is on the bottom, 6 over 9. Okay, because I went from 4 to 6, so I have to go from 6 to 9. Okay, it's very important that you set it up correctly, because if you don't, it's not going to work out. Okay, how do I solve a proportion?
Equal to what?
Oh, you do know, because y'all learned this in middle school. Come on now.
That's
100.
Wait.
It has to equal to 100.
360.
Don't have to equal anything.
You're supposed to.
How? What? Cross multiply. You remember the butterfly method that they taught you all? 6 and 6, 36. 4 and 9, 36. Does 36 equal 36? Yes.
Ain't there like a trick to that? That
It's
was
like
a trick.
100. I promise you.
Yeah,
It's like 100 or something.
I think you talking about percent.
I think that's a trick.
Yeah, I think that's a
Never
trick.
mind.
Yeah, like an easier way.
I'm pretty
Because
sure
I
there
was
is a
like
trick.
terrible about multiplication at that time.
I swear there was too.
Yeah, I could.
I mean, you could reduce them.
Oh, that's probably what it was.
Okay. So Elijah said, is there another way to do this? Yes. What does 4 over 6 reduce down to?
2 over 3.
2 over 3. What does 6 over 9 reduce down to? 2 over 3. Does 2 over 3 equal 2 over 3? Yes.
That's what it was.
So that also works. If you can reduce them down, if you're better at dividing and you can reduce them down to see if they're equal, that's another way to do this. That's okay.
I think so.
Whatever is better for you. Yes. Okay. So we can say the triangle MNL is similar to triangle PRQ. Woo.
I think what you said.
After this, we're just going to glue everything in so you don't lose anything. That's what we're going to do.
Oh my God, I thought you were going to say after this.
No, Kenley. Kenley.
Yeah, you got issues.
Okay. This is kind of like the first example we did. We've got a triangle inside of a triangle. So you've got this triangle here. Thank you. Okay, so there's my first triangle, my big old triangle. Big old triangle. Okay. Here's my tiny triangle inside.
Hey, give me another color.
I really wish that light would stop shining into my room
What side?
because it would make it so much easier to see this.
It's better to see.
Bro, I'm tired.
Honey, the lights are off.
I mean, I'm talking about that.
No, I need the sun to stop shining in here.
He said keep telling us.
Yeah, but it's
Hey, Alexa, turn off the sun.
Like covered up.
'Cause that does that. If I shut off this light, this is what you get. You can't even see it at all.
I can.
I can't.
I'm blind.
Okay, so remember.
You had to be there.
Okay, remember, we are trying to do side, angle, side. So these triangles must have an angle that is the same. Where is it? L. L is the same. Okay. So My small triangle has a side of 6 and a side of 10. Okay, my small triangle has a side of 6 and a side of 10. What does my big triangle have?
3,
5.
Oh, no, 10 is 9
9
and
and
15.
9 and 15.
Huh?
Okay.
Hold on. Add them together.
Stop.
One big triangle.
It's one big triangle. So it's this entire side. This small piece is 3, this big piece is, or this other piece is 6. So 3 plus 6 gives me 9. Same thing with the other side. I've got 10 and 5, which makes my big one 15. So 9 goes with my 6 and 15 goes with my 10.
Oh, my brain hurt.
With the 6 going up above the 9.
Okay, so you can do 6 over 9. Small triangle over the big triangle is equal to, if I do 6 first and 9 second, that means my second one has to be 10 first and 15 second. Okay, so let's try Bobo's way. What is 6/9 divisible by? 3. Each time we can divide by 3. So 6 divided by 3 takes me to 2, and 9 becomes 3. What can I divide 10 and 15 by? 5, which leaves me with 2 and 3. Does 2/3 equal 2/3? Yes.
If this is better, raise your hand.
Okay. If you don't like that, if you prefer the butterfly method, I'm going to do the butterfly method. Okay. So you can still butterfly it. 9 times 10 is 90. 6 times 15 is 90. Okay. So again, I don't care which way you do it. Please stop talking over me, or I will just still test on Friday and say, forget it. Because I'm not sure if it's you don't understand or you don't understand because you don't want to focus today. I don't know what it is. I have no problem stopping if you just don't understand, but if you're just not going to focus, I'm just going to watch you fail. I don't care. All right. The last one is a pain. Okay. Because this one is side, side, side. Which means I have to prove that all 3 pairs of sides are proportional. So you need to do 3 separate proportions in order for this to work. You cannot just do one and move on with your life. You have to do all 3. So let's take a look at these. Okay. So if I've got, if I've got side 7 on this triangle,
30.
what's that going to go with on the other one?
30.
No.
21.
Oh,
Why 21?
Because 21 is divisible.
It has nothing to do with it being divisible.
It's like
It's on the opposite
it's
side.
flipped. It's flipped.
Oh, yeah, it's reflective.
But they don't tell you that, so how do I know that 7 goes with 21?
That's the shorter one, and that's the other one's the longer one.
Okay, if you take a look at the first triangle, you've got 7, 12, and 15. So 7 is your smallest side, which means it should match up with the smallest side on the other triangle.
20.
Okay, so you've got 21, 30, and 45. So your smallest one on this one is 21. Okay, so 12 then goes with 30 because those are your middle ones. And 15 goes with 45. Okay, I always like to mark them. That way I don't have to sit there and play the guessing game on what goes with what. Now I know, now I can just solve. So I need to do 3 sets of proportions. So my first one, let's do 7 over 12. So I did the small side and the middle side, which means my second fraction should be 21 and 30, because 7 goes with 21, 12 goes with 30. So my second one has to be 21 over 30.
Wait, I have a question.
Yes.
Why don't you put 7 over 12 and not?
You could have done 7 over 21 and 12 over 30. Okay. That would have also worked. Okay. So do we prefer Bobo's way to look at this, or do we prefer cross multiplying? Cross multiplying. Bobo, you do yours. If you prefer Bobo's way, go ahead and do Bobo's way. If you prefer mine, we'll stick with mine. Okay. Yes.
How do we know which one's to put first?
What do you mean?
Like 7 over 12 and then.
You just pick a first fraction and then do your second one according to that. So I could have also done, you could have done. I'm probably gonna have to stop after this example so you have time to pack up. We'll look at this again tomorrow. All right. So you could have done 7 over 21, which is your small sides on both triangles. And you could have set that equal to 12 over 30. Your middle sides.
Either way.
Either way, it comes out to be the same. Because look what happens when you cross multiply. When I cross multiply on that one, I get 7 times 30. 7 times 30. I get 12 times 21. So either way, they both work. So there are several ways you can set up your proportions. My suggestion to you is come up with the first fraction and then do the other one according to that.
So why couldn't you do 7, 21 and then 50, 45? Or you could do that. You did.
Okay, so you said 721, 7 over 21, and you said 15 over 45?
Yeah. You could do that.
We're gonna have to do that one too.
Oh.
We have to do 3 sets of them. So that is another one that we're going to have to solve.
So does 721 have to be with each one? Like.
So you'll do, this is small and middle, this is small and big, okay? So small and middle number, small and big numbers, and then I've got to do middle and big numbers as well. So you've got to do 3 sets of proportions. Unless you get one that's not, then you can stop.
Okay, well the first one
So
is
is that
not.
over
Right.
the side? Like,
Minute.
you put like one small side over each other and then the other side over.
If you do small over small, you then have to do medium over medium.
They don't equal.
Okay, you said this doesn't equal?
Uh-uh.
What's 7 times 30?
200, wait.
210.
210. What's 12 times 21?
252.
252. That automatically doesn't work, so that means these are not similar.
So y'all have to go through all of them?
Nope, you only have to go through all of them if they work. If they work, you have to check all 3.
So one
But
of
as
them
soon
work-
as one of them doesn't work, you're done. It's not similar, stop.
I
one
hate
of them
you.
work?
Huh?
Can one of them work and not the other?
No.
No, they all have to work in
I'm
order
talking
to
about
use.
like ain't no problem. Can one of them work?
Oh, absolutely, they're gonna screw you like that, which is why you have to check all 3. If the first one comes out to be right, you have to check the second one. If that comes out to be right, you have to check that third one. Because I guarantee you they're gonna put something on your test where the first 2 work, and you're gonna get to that third one, and you're gonna assume it works, and you're gonna put similar,
Be like,
and it's
man,
gonna
these
be
don't work. Wrong.
wrong.
That's what I swear.
Okay,